adding some fractions. Remember that when you add fractions, you must have a common denominator. So that's this number down here. Must be the same. Now in order to make these two denominators the same, I'm going to take my second fraction and multiply the top and the bottom by 2. This will change that second fraction just a little bit. So it's going to change my problem into 17 over 22 plus 4 all over 22. Now once you get these denominators the same, go ahead and just add the top numbers. So 17 plus 4 gives us 21. The last step is to check this and make sure that it is reduced or in lowest terms. Well, right now I don't see any common factors, so I'm just going to leave this as 21 over 22. Welcome! Today I'm going to show you how to evaluate an absolute value. And if you've never seen an absolute value before, it's basically these two goalpost things right here. You want to see the double line and the number in between them. Now the secret to evaluating an absolute value is basically take the number inside of the goalpost and make it positive. And that's all you really have to do. So in the expression that I have laid out here, there are 1, 2, 3 absolute values. Let's see how we evaluate each of these. So in the first one I have a negative 18 inside absolute value, and I make that a positive 18. Moving on to the next one, a negative 11 becomes a positive 11. And the last one, well, it's a positive 3. And so I still keep it a positive 3. Alright. Now you may have noticed that I have a few other signs floating around here, like the negative sign, the plus sign, the negative sign. None of those signs are inside the absolute value. So we're going to keep them just as they are. So our expression at this point is a negative 18, a positive 11, and a negative 3. Now once you've taken care of all the absolute value signs, it's just a matter of simplifying from here. So think, negative 18 plus 11, let's see what happens there. I guess that'd be a negative 7. And then finally we'll take our negative 7, subtract 3, and end up with an answer of negative 10. So see, not so bad at all. Very interesting factoring technique known as factoring using the AC method. And this is basically used for trinomials or polynomials that have 1, 2, 3 terms. Okay? Now this is a great method, and it works best if there's an actual coefficient on your x squared, and as long as the numbers aren't too large. Okay? So there are several steps to it. Watch how they all fall out. The first step to the AC method is to multiply the a and c coefficients together. That'd be the 6 and the negative 15. So 6 times negative 15 gives me a negative 90. Now what I want to do now is search for two numbers that multiply to negative 90 but add to my b term. Now what's my b term? It's basically the coefficient of the middle term. So let's see if we can do this. Remember, we're looking for two numbers that multiply to be negative 90, but they add to give us a 1. Well, I think something came to mind. I think 10 and negative 9 will work. So 10 times negative 9 multiply to give us negative 90, but 10 plus negative 9 give us a positive 1. That's perfect. Once you find these two numbers, you take them and you split up your middle term using these two new ones. So I'm going to write a 10x minus a 9x minus 15. So pause for a moment and notice how even though I've split up my x into these two terms, I really haven't changed the problem because sure enough 10x minus 9x equals just 1x. Alright? Now let's see exactly why I've done that. So why did I split the middle term using this AC method? Well, the reason is now I can use factor by grouping and take these terms two at a time. Okay? So let's first look at these two and ask ourselves, do they have anything in common? Well, 6 and 10 I can factor out at 2, And it looks like they both contain an x, so we will take out a 2x. What's left over? Well, a 3x plus 5. Very interesting. Okay. For the next two terms, I want to do the same exact thing. Is there anything that's common to both that I can pull out? Hey, look at that. A negative 9 and a negative 15. Well, I think one thing that will be common to both is probably a negative 3. Well, if I take out a negative 3, what's going to be left over? So negative 3 times what is negative 9? Well, a positive 3x. And negative 3 times what will be a negative 15? Well, a positive 5. Now that's pretty interesting, because look at now what we have. This is essentially one term, minus, and all of this is essentially one term. And moreover, they both contain this, the 3x plus 5. It means we are going to factor out the 3x plus 5. What will be left after we factor that? Well, the 2x and the minus 3. And there you have it. We've taken our original polynomial, the 6x squared plus x minus 15, and we've shown that it factors into 3x plus 5 and 2x minus 3. Now, it's kind of an interesting process, but you may be looking at it and you might not be convinced that that is really how it factors. But if you're not convinced, go ahead and take a moment to multiply this back together. 3x squared times 2x, this will give us a 6x squared. The outside terms will give us a minus 9x. The inside terms will give us a plus 10x. And the last terms will give us a minus 15. So combining, we can see that sure enough, it does equal the original. So this is really how our trinomial factors.